We have come here for a new lecture on a new topic. We're going to start advanced level problems on rotational mechanics. Rotational mechanics is a large chapter containing so many subtopics, and therefore it's a very important chapter within mechanics and a favorite with examiners. We shall go for a variety of problems on this chapter in a series of lectures here, and in choosing the problems, I shall follow the same order in which I have taught various subtopics within this chapter. Although the problems of advanced level, we shall classify them further using these dot marks, using one dot for problems which are relatively simple, two dots for problems of moderate difficulty, and three dots for problems which are rather challenging or tough. So let's go for the first problem in this series. Moving on to part B of the question, they are telling density of copper. Well, this is given here. Let me start writing down the information in part B of the question, that for copper density is 8.9 into 10 to the power 3 kg per meter cube. Breaking stress, that is the maximum stress that a copper rod can sustain. So the symbol for that would be sigma max, isn't it? This is the maximum value of stress permissible in a rod of copper. That is given to be 2.3 into 10 to the power 8 Newton per meter square. And also for copper they have given the value of K already defined earlier here in part A of the question. The value of K is 60 per meter square. You already have verified this unusual unit of K at the beginning of the problem. So what is the maximum permissible angular velocity of a copper rod as described in the figure on the left hand side? So this was the figure, right? So this last relationship is showing me that the constant K is given by rho into omega square by twice sigma. It follows from here omega square can be expressed to be 2K into sigma by rho. Here rho is the density, K is the constant appearing in the expression for cross-sectional area here. This sigma is the stress in the rod and omega is the angular velocity of rotation of the rod. It's obvious from the relationship that as this omega goes up, increased, the stress sigma also goes up. And at a particular limiting value of omega, this stress will be equal to the breaking stress above which the rod will break or snap. So we might write down for that limiting situation the maximum value of angular velocity, well, squared, this is coming out to be 2K by rho into sigma max. Square rooting both sides, we can write down this is coming out to be omega max is equal to square root of twice K into sigma max divided by rho. Now we'll be putting the values. This is square root of 2 into the value of K 60 per meter square, the value of sigma max, that is the breaking stress, given 2.3 into 10 to the power 8 Newton per meter square, and this is divided by the density of copper, which is 8.9 into 10 to the power 3 kg per meter cube. Remember, the whole thing is under square root. Make the calculation and show in two significant figures the value of omega max I am getting to be 1.8 into 10 to the power 3 radian per second. We can also convert it into RPM, that's revolutions per minute, using the conversion factor 1.8 into 10 to the power 3 into, well, you divide by 2 pi, you get this number of revolutions, and per minute means multiplied by 60, and this is coming out to be 1.7 into 10 to the power 4 revolutions per minute, RPM in abbreviation. So this is the answer of part B of the question. Our conclusion is, if the angular velocity is raised to a value of 1.8 into 10 to the power 3 radian per second, then the rod is on the verge of breaking, and that is the maximum permissible value of angular velocity as well. The complete solution of the problem is here.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.